Hey, what's up everyone? This is page 218, but we're continuing to talk about how diagonals will create quadrilaterals and how we're going to make conjectures about the shape of the quadrilateral based upon the diagonals. So join me on page 218. We've already done part one, or the first part of this page. That was where we created the circle with the shape that's in here. We're going to get to a specific conclusion about what type of shape that is, and is that always true? You have drawn 4 triangles. Use these triangles to analyze the lengths of each side of the quadrilateral. What did you notice? So in order to do that, sorry, a little zooming, autofocus here. We've got 4 triangles in this shape. Let me go ahead and just color them in. So if you have color pencils or if you have highlighters, whatever you're using, color pencils might be the good one for right now. I'm going to color in this triangle right here, RPT. All right, RPT has a spike, and an angle. And it's got a matching partner on the other side of this quadrilateral shape, SPQ. There's a triangle. They should be the same size. They should be congruent. They should be congruent because spike and this angle are exactly the same, but on the other side, like a reflection with spike and the angle between. That's SAS. Furthermore, we have triangle QPT. So there's our triangle with spike, different angle, same spike. And then on the other side, ooh, these are isosceles triangles. 2 sides of the triangles match. That makes them isosceles. Color-wise, love the color. Orange and red, those 2 triangles, they are also congruent by SAS. So we're gonna analyze right here. Use these triangles to analyze the lengths of each side of the quadrilateral. The thing is, page 217 created a square. All of the triangles on the inside were the same, but not here. In this one, this triangle is going to be exactly the same as the one on the other side. A little reflection flippy-do would show you. That means that this line segment, RT, should have a matching line segment on the other side, because if they're the same triangle, then all of the pieces are the same. With that same logic, QPT as a triangle should be exactly the same as SPR. Those should be exactly the same triangle because of SAS. Side, angle, side. Matches side, angle, side. So this one, 3 spikes. Pay attention. 1, 2, 3. 1, 2, 3. We have to use 3 spikes because blue and orange triangles, or whatever that color is, they're not the same size. So if you use 2 spikes here, you cannot use 2 spikes again, unless it's on a side from a triangle that matched it. So we're going to make some very specific statements in this problem. You have drawn 4 triangles. What do you notice? Well, here's one thing that I notice. I notice that there are 2 pairs of congruent sides. Let's name them. So in order to name them, we're going to name QT is congruent to SR. And RT is congruent to SQ. It might be helpful in this moment to bring a little highlight in. So I'm going to highlight RT and SQ the same way. And then don't have a matching highlighter color here, but I know you've got several because I've let you borrow them. So use your other highlight colors to highlight and highlight. Okay. Let's take a look at the next part of this one, part C. Determine the measure of each interior angle of the quadrilateral. It's because, it's because of this vocabulary word, inscribed angle, right? Inscribed angle, that all of the angles of this quadrilateral are 90 degrees. I can tell you more, but I'll leave it with, let's just show it. If you take the corner of a piece of paper, like patty paper for instance, or really I mean like any paper, it should make a 90-degree angle, and we can just kind of like nudge it there into angle Q, nudge it there into angle S, nudge it there into angle R, put it into angle T, a little bit of like line it up and measurements. Turns out all of those angles are all 90 degrees because a piece of paper, the corner fits perfectly into that. I mean, the real reason is because of this. You're making inscribed angles on a diameter, which is 180 degrees, and half of 180 is 90 degrees. But that's from the previous lesson. Go watch those videos. The inscribed angle guarantees that the measure of each interior angle of the quadrilateral, 90. We should name them, though. So that's angle TQS, angle RTQ, angle SRT, and angle strategic recovery and tactics. I don't know. QSR. Once again, please pay attention to the middle letter. The middle letter is what lets us know the angle we're focused on, but you need 3 of them to talk about it. They are all 90-degree angles, right angles. All right. Therefore, what names can we use to describe this quadrilateral? QSRT. Can't say square. Not all 4 sides are the same. You should also know that because that don't look like a square. It does look like a rectangle. And a rectangle is a special type of parallelogram. And being a parallelogram where 2 sides are the same, some might classify a parallelogram as a special type of trapezoid, where a trapezoid says at least 1 pair of sides is parallel. So we could say it's maybe a trapezoid. This is really up for debate, though. And then last of all, it's certainly a quadrilateral. Quadrilateral. Those are the classifications for this shape. Thank you for watching this video. I hope you got something from it. You should, because that's a pretty, actually beautiful picture. Put some color, do math in color. See you in the next video. Page 219 is next.